Hi everyone, welcome to the Art of the Possible series. I'm Nihali Niyogi and I'm a principal cloud solution architect at Microsoft focused on advanced networking. Today's topic is Palo Alto Cloud NGFW in Azure. Last year we did part 1 of the Palo Alto NGFW video with Anton, and in this video we will refresh the content, talk about new features. We've added demos to show the deployment experience and advanced scenario presentation. With me, I have a lot of networking energy on the call. I have my co host Cynthia Treger, who is an Azure Networking Global Black Belt. Cynthia is partnering with me on the ISV series over the last year or so, and we also have SMEs Shruthi, Mays, and Daniel from Microsoft joining the team. Shruti and Mays have prepared a fantastic presentation on advanced scenarios that we will show you later in the video. From the Palo Alto side, we have Salman and Raj who would be giving us a briefing on new features and demo on the Strata Cloud Manager. With that, welcome everyone, and let's go through a round of introductions. We'll start with you, Cynthia.
Thanks, Nihali. Hi, everyone. So I'm Cynthia. I'm based in France. And as Nihali said, I'm part of the Advanced Networking GBB team, which is a team of global pre-sales consultants. And I'm focused on Azure networking. And before joining Microsoft and the GBB team 3 years ago, I spent 20 years on the telco side. Mace? To you.
Thanks, Cynthia. Hi, everyone. My name is Maisel Jibari, and I'm currently a solution engineer, infra solution engineer at Microsoft. Previously, I was a global black belt SME in networking based in Dallas. Shruthi?
Hi, everyone. My name is Shruthi. I am also a senior cloud and AI infra, and I was part of the global black belt networking team along with all my beautiful peers here. And with that, I hand over to you, Daniel.
Thank you, Shruti. Hi, everyone. Daniel Mauser. I'm also a solution engineer, former networking GBB, and happy to be here. I'm based in Dallas, Texas, and I'm going to hand it over to Salman.
Yeah, thanks, Daniel. Hello, everyone. My name is Salman Sayed. I'm with Palo Alto Network. I'm a senior technical marketing engineer, mainly focused on Cloud NGFW service. I've been with Palo Alto Network for more than 4.5 years. And in my role, I work with a lot of customers who are currently deploying, who are actually new to the cloud or have been in cloud for a long time. And I'm helping them deploy this service, the Cloud NGFW service in Azure.
Excellent. Welcome everyone again. Thank you, Salman, again for your partnership. So I will turn it over to you when you are ready. You can share your screen.
Sure. Thanks, Nelly. Can you see my screen?
Yes, we can see it.
So yeah, today I'll give you an overview of the Cloud NGFW for Azure service. We'll give you details about how this service works, and then talk about the 2 deployment models, and then also cover the new features that we are releasing very soon. So as you all know that Cloud NGFW for Azure is a cloud native managed next generation firewall service. It is built by Palo Alto Networks and delivered as a native Azure service in collaboration with Microsoft. So it was created to address the fundamental challenge of securing modern cloud environments. And by deeply integrating with the Azure platform, we eliminate the operational burden of managing traditional firewalls, allowing the organizations to leverage best-in-class security without the heavy lifting. And then as an Azure native ISV managed service, Cloud NGFW for Azure is designed for effortless security. Customers can easily deploy a powerful next generation firewall in minutes directly from the Azure portal operating it just like any other Azure native service. And for teams that live and breathe infrastructure at code, it also offers seamless automation and CI/CD pipeline integration with full support for the native Azure API, CLI, SDK, and Terraform providers. And this simplicity ensures that security can keep pace with your development cycles. And also a fragmented security posture across on-premises and cloud environment is also a significant risk. So that's why Cloud NGFW for Azure solved this by allowing for easy extension of customer security policies. Using a centralized management console like Panorama or SCM, customer can ensure that the same consistent best-in-class security policies are applied to all of their applications, no matter where they are. So this unified approach eliminates security gaps and then provides a single source of truth for the entire security posture. It's simplifying the operation and ensuring compliance. So Cloud NGFW, as I mentioned before, is a fully managed service, and it offers the same best-in-class security that customers can get from any other Palo Alto network product, whether it's a hardware or VM firewall. And then there we offer two deployment models. We have the VNET and virtual WAN, and then I will also cover these two deployment models in details later in the section. So if you look at this slide, the bottom portion is Palo Alto network responsibility. So we will deploy not only the firewall, but also the infrastructure for the customers. And then on top of it, we will also manage the software and content update for them, so they do not have to worry about that. This service is highly scalable and highly reliable. What it means that we support auto scaling. This service can support a throughput of around 100 gigs. And then we also offer an SLA of 99.99%. So that's Palo Alto network responsibility. And as a customer, their responsibility is just to create firewall rules that they can do it either through native Azure native console, or they can use Palo Alto network policy management platform like Panorama or SCM. And the other responsibility is they can route the traffic to the firewall using the IPs. So that's the Palo Alto network and customer responsibility for this service. And then we also integrate with Azure native services. We integrate with keywords. For example, if customers want to use inbound and outbound decryption, they can store the certificates in keywords, and the firewall will be able to access those certificates for inbound and outbound decryptions. We also have integration with virtual network and also with vWAN. Customers can deploy this service inside vWAN Hub. And then we also integrate with different Terraform tools and also the CLI, Azure CLI PowerShell, Azure Portal. We also have integration with that. So if customer want to automate the process of deploying the resource, they can do that using Terraform. And then for logging, customers can also store logs in Azure Log Analytics. So we also have integration with Azure Logging and Metrics. And then, as I mentioned before, it's a fully managed service. So customers do not have to manage any infrastructure. We provide the complete lifecycle management of the firewall. So the customer do not have to worry about any of these things. And on top of it, they will get the same best-in-class security that they can get from any other Palo Alto network products. On the architecture side, if you look on the back ends, how this service works is whenever a customer go to the Azure portal and deploy this service, in the back end, Palo Alto Network has its own Azure subscription. And whenever a customer start the process of deploying the resource in the back end, what we will do is we will create two load balancer for the customers, a public load balancer and a private load balancer. And in between those load balancer, we will create the VMSS. And then in those VMSS, we'll deploy the VM series firewall. So for example, if customer is deploying this resource in a region where they have 3 AZs, then we will deploy 3 VM series firewall to start this service. So as you can see here, there are 2 load balancers that we will deploy for the customers. We'll create a VMSS, and then in each AZ, we'll deploy 1 VM series firewall to start this service. And as I mentioned before, we support auto scaling. So we'll continuously monitor this environment. And as customers are sending more traffic, or the session count, or the CPU utilization of the firewall is going up, we'll slowly add more firewalls for the customer without them noticing it. So we support auto scaling. And then we have different metrics that we use for auto scaling, and I will also cover that later in the section. So that's how this service works. And this whole resource is fully dedicated to a single customer. It's not shared with any other customer. And then we support DNET. So any traffic coming from internet, inbound connection, we perform the DNET. And for outbound traffic, we support the source net. So we perform the source net. We also support DNS proxy configuration, and everything can be done using the Azure console. So it's natively integrated into the Azure console. So customers can just log into the console, deploy this resource, and then they can also configure the DNET and SNET from the same Azure console. We support 2 deployment architecture right now. The first one is the VNET architecture. So in VNET architecture is more of a hub and spoke topology. We will create a hub VNET, and then all the other customer VNET can be paired with hub VNET. So any traffic coming from internet or going out to internet or east-west will first go to the hub VNET, and then after the inspection, it will go to the destination. The second architecture is the vWAN architecture. This service is also integrated with vWAN Hub. So customer will be able to deploy this service inside vWAN Hub. So these are the 2 architecture, the VNET architecture and the vWAN architecture we support with this service. So in the VNET architecture, as you can see here, on the customer side, we will create a hub VNET. And then inside this hub VNET, we will have 2 subnets. One will be the public subnet and other will be the private subnet. And using the VNet injection, we will connect this hub VNet to our Palo Alto network subscription, as you can see here. So whenever our customer create a resource in the backend, as you can see here in Palo Alto network subscription, we will have two load balancer, a public and a private. And between these load balancer, we also call it a more of a sandwich mode, where the VM series firewall sits in between 2 load balancer, public and a private. So we will deploy the VM series firewall between these 2 load balancer. And same thing, these firewall will have 2 interfaces, a trust interface that will be part of the private subnet, and then we will also have the untrust interface that will be part of the public subnet. So this hub VNet will be connected to the Palo Alto network subscription. So any traffic coming from a spoke VNet will go to the firewall through this hub VNet for inspection. So that's how the hub topology, or you can say the VNet deployment, works. This is just another explanation of how it's connected to the backend. In customer subscription, we will have the hub VNet. Hub VNet will have 2 subnets, the public and the private. And then in the backend in Palo Alto network subscription, we will deploy the firewalls for you, for the customer. And the vWAN deployment is also very similar, but the only difference is now the deployment is inside vWAN Hub. So customers can go, whenever they go and deploy this service, they can select whether they want to go with the VNet architecture or the vWAN architecture. And I think later on in this webinar, Nihali will cover how the 2 different deployment works. We will go through the flow, how you can deploy this service in Azure console. Right, so in the vWAN architecture, this service can deploy this service inside vWAN Hub. And then after that, you can update the routing intent and policy to send traffic, for example, the internet traffic going out to the internet, or your east-west traffic, the traffic between the VNets or from VNets to your on-prem network. You will be able to send it to the firewall resource for inspection. So these are the 2 architecture we support with this service, the VNet architecture and also the vWAN architecture. Now let's quickly talk about the new features that we have released. The first one is the SCM integration. Customers can now use SCM, our Strata Cloud Manager, to create policies for this service. So with the integration of Strata Cloud Manager across Azure and other environments, customers can now manage policies more seamlessly. They can create policies not only for Cloud NGFW, but also for their hardware and software firewall running in different environments. So with this, we ensure consistent production across all on-prem and cloud environments, and regardless of where workloads are deployed, security and compliance standards are uniformly enforced through SCM, and this consistency simplifies governance and minimize the risk of misconfiguration. So that's the benefit customers can get through SCM. They can manage their policies for different platforms, for Cloud NGFW, for VM series firewall, and the hardware firewall from a single place. And then they will get full visibility into their environment. They will be able to see what kind of firewalls are running, the traffic going through the firewall, thread detected, how many threads were blocked. So all the visibility they will be able to get through this platform. The second big feature is the multi-dimensional scaling. As I mentioned before, we support auto scaling. So we have different metrics for auto scaling. Before, when we started this service, we only support CPU utilization as a metric. So whenever the CPU utilization hit 40%, we used to do the scale out. But now we have added more metrics. So for example, now customers can also use session count. So if the session count of the firewall hits 40%, then we're going to go and do the auto scaling. We also support throughput, and then the SNET port utilization. So these are the different metrics we have added for multi-dimensional scaling. And our multi-dimensional scaling timers are very aggressive. So we just wait for 5 minutes. For example, if the session count hit 40% of the limit, we wait for 5 minutes and we're going to go and scale out, add more firewalls for the customer without them even noticing it. And then for scale in, we wait for 8 hours. So for example, for next 8 hours, if the CPU utilization or the throughput or the session count went down to 20%, then we wait for 8 hours, then we go and do the scale in. So our scale out timers are very aggressive. We only wait for 5 minutes, but for scale in, we wait for 8 hours and continuously monitor your environment. So for 8 hours, if your utilization, if your CPU utilization or the session count is less than 20%, then we go ahead and scale in. So that's the big feature that we introduced with this service. And the next one is we also introduced the integration with Azure App Insight. So now customer will be able to monitor the health of this resource from the Azure console. Then they can just go to the log analytic workspace and they will be able to monitor the bytes in and bytes out of this resource. They will be able to see the CPU, different other metrics like usage pattern, and then they can also set up alerts. They can create custom thresholds, and based on that, they will get alerts. So that's another big feature that we release for this service. And then I think that's it from my side. And later on, we will also give you a demo of Strata Cloud Manager, how you can create policies through Strata Cloud Manager, and then what are the different visibility options available for customer in Strata Cloud Manager. Back to you, Nihali.
Yeah, it looks like Shruthi has a question.
Sure, go ahead, Shruthi.
Hey, Salman, a quick question. So you said when we are auto scaling, you also support SNAT port based auto scaling?
Yes.
So if there's a port exhaustion, sorry, go ahead.
Yeah, there's a port exhaustion limit, right? So whenever we hit that 40% of that limit, we're gonna go and add more firewalls for the customers. Yes.
Okay, so 40% is the limit. The moment you hit, okay.
Yeah. We do not wait for 100%. We only wait for 40%. As soon as you hit the 40% of the session count, the S-node port utilization limit, then we'll go ahead and add more firewalls. Yes.
Oh, perfect. Thanks, Salman.
Okay. Yeah. Excellent presentation. Thanks, Salman and Shruthi. So what we will do next is we will demo the full deployment for both the vWAN deployment as well as the VNET deployment. So, and then we'll go back into our designs. We'll do a design session with a draw.io as well. So, because this takes a few minutes to deploy, so let's go ahead and kick off the deployment. And before that, I want to show you my existing vWAN. So first, well, let's go to vWAN. I want to show the current state of the vWAN. So I have a vWAN deployed with 2 vHubs. And if we go into the vHub, notice that under network appliance or SaaS solutions, I don't have anything. Okay. And then likewise in the other vHub, under network and SaaS solution, I don't have anything. And then if I go to the vHub and show you the routing intent screen, you can see that I haven't integrated any firewall. Okay, so with that as a starting point, is there anything else you want to see on the vWAN side, Shruti or Salman, before we go and deploy it?
No, I think that's, yeah, the main thing is the routing intent and policy. So once we deploy the firewall resource, after that we can go back here and update that.
Yeah.
Yep.
Sure.
Can you also validate that you don't have any custom route tables? What you're using is just the default route table.
Oh, good point. So yeah, so we have the default and no custom route table, Shruti, looks like.
Perfect. That's what we want. Yes.
Perfect. So in terms of the workflow, there are 2 distinct ways that you can do it. They do the same thing. You can go to the SaaS solution and hit create SaaS over here. And then there's another method, which is what we will be using, is called Cloud NGFW. So when you search for Cloud NGFW over here, you get 2 options. Well, this is the option. This creates the rule set, and we'll talk about that in a little bit. So let's go to the Cloud NGFW, and then we'll create. We'll create a new resource group. Okay. And we'll call it NGFW. And we will call it vWAN because we will have another one in the hub spoke model. And this is where maybe you can talk a little bit about the different plans. I'll come back and we'll revisit this once we kick it off, because this is often we get questions about this, Salman. So once I kick off the install, we'll come back on this one. And then on the networking side, this is the key, right? So this is where you would integrate it with either the virtual network or the vWAN hub. So we'll pick this and we'll pick our East US 2 and we'll say create new. And then additional prefixes to private traffic range. Now this has to match what you define in vWAN. For now, we won't use that one. And then SNET is enabled. And let's see, you can also use when you say use IP above, you can also use the public IP for SNET, but we'll keep different IPs for SNET. Okay, and then anything else on this screen that you want to call out, both either Shruti or Salman? It's the most important screen here.
Yeah. I think these are the only thing. Yeah, public address. I think you can add more public addresses right now, or you can also add it later. That will help if you want to configure the DNet. Yeah.
Right.
Yeah.
So we'll just say create new. Here you could pick either the Panorama or Rulestack, and the Strata Cloud Manager is here as well. So we'll use the Azure Rulestack for now. It creates one, and I believe we'll go take a look. I believe the default is allow everything, and we can change that. And then DNS proxy, if you want to enable that. And then, oops, I think I forgot to check off the terms. And then review and create. So we'll go ahead and hit create here. It does take about 15 minutes the last time I timed it. So while it deploys it, Salman, you want to talk a little bit about how does one go about picking this? How does this get configured?
Yeah, so there are two options when it comes to the pricing or the plan. Customer can either do pay-as-you-go model, where they can just start the service and then pay directly to Microsoft. So whatever they use, they will get a bill from Microsoft for this service. So that's one way to use this service. We call it pay-as-you-go. The other option is credit model, where customers can buy credits from Palo Alto Networks. And once they buy the credits, we'll go ahead and deposit those credits in their tenant, and then they can use those credits to deploy the resources or to enable different subscription, like Palo Alto Network subscription, for example, the advanced threat prevention and advanced URL filtering. Or if they are planning to use Panorama or SCM, then they can also use that. So these are the two options: pay-as-you-go model, where they get billed directly from Microsoft. The other is the credit models, where they can buy credits from Palo Alto Networks or any other partners, and they can use those credits to deploy the resources.
Got it. And so after you enable it, it will show up in this drop down.
Yeah, if you have buy the credit, then it will show up here, and then you can use those credits.
There is also the third experience where you go in here and create a resource and maybe talk through the right option here for Cloud NGFW for vWAN. Is there one here, or is the experience only from the way we did it?
Yeah, so here you just have to go and subscribe to the service. So as you can see here, there are different options. So for a new customer who want to try this service the first time, what they can do is they can select the third option from the top, the Cloud Next Gen Firewall by Palo Alto Networks. And that's the way to go. And then they can just click on subscribe, and they can start using this service. So we offer a 30-day free trial. They can use this service for free for 30 days. And after 30 days, it will automatically convert into a pay-as-you-go. So whatever they use after 30 days, they will get a bill from Microsoft. Or after that, if they want, they can buy credits from us and use those credits for the deployment. So that's the only option they have right now. And to select the VNET in vWAN Hub is when they deploy the resource, as you just showed during your deployment, the two options. That's there they have to select whether they want to do the VNET deployment or the vWAN Hub. There is no separate marketplace listing for vWAN Hub. That's the only one. And during the deployment, they have to select whether they want to do VNET or vWAN Hub. Yeah.
Got it. Thank you for that clarity. Yeah, that's something we don't have enough information about the licensing and how that works. So customers have to work directly with their Palo representatives to get that.
To get the credits, yes.
Yes, to get the
credits. They can just go to the marketplace and start it. They can
right
start
here.
themselves.
So that's the experience. Yeah.
Yeah,
so
you can just start deployment. Yes, correct.
Okay. Oh, and you can select this pay as you go. Yes, I should have captured that one. Okay. Okay, perfect. So let's see how our deployment is doing. It's still going. So while the deployment is going, I'll just quickly run through a couple of flows and what we are going to be doing and what. So if you've been following along with us on the vWAN series, we've done deep dive on just vWAN. So I'm going to go straight into the scenario with routing intent. Let me hide the shapes. Yeah, so here you see that we have a routing intent. This is the icon for routing intent that is turned on in the vHub. And what will happen is we have the Cloud NGFW that we're just deploying. So we kicked off the deployment. So from a placement perspective, it sits right in the vHub. And then what will happen is we'll run a few tests once the deployment is done. So all of the internet bound traffic. So with routing intent, you get two options, and I have listed those two options over here. So you get the option to steer the traffic, the internet bound traffic to the firewall, or the private traffic through the firewall. Or you could either have just the internet as well. And so what these flows are showing is that when you egress from the spoke, you will traverse this firewall, and we'll run a demo to show you that it is indeed traversing the firewall. And then we can also advertise 0, down to the branches. Of course, you can't advertise 0 across the inter-hub link. And then in terms of the private traffic, all of your private traffic would also be traversing the firewall in the vHub. So this is the NGFW. And then I have just shown this corner case that for ER to ER transit, the global reach will take precedence, but you can do it with a support case. Shruthi, anything you want to add on our flows? I know that you work on this extensively.
Not really, Nihali. I think this flow pretty much covers everything.
All
A
of
lot
the
of things.
flows. Yeah, and then I have one more layer for inter-hub. So inter-hub will traverse the firewall twice. So if this spoke is talking to this HQ, it would traverse the firewall twice. And then I have added a layer for DNET because we'll be demoing that. So this external user, once we set up DNET on this firewall, we'll set up a DNET to this VM, and they can hit it with this path. Anything else, Salman, that you want to add on this architecture?
Yeah, for the egress traffic, the firewall will do the source net, right? So I think that's what we can also do it from Azure console.
Yeah, so this is the SNet. So when this VM, if we kick off the traffic from here, this VM will egress using that SNet. Yeah, so we'll demo all of that. Good point. Okay, so with that, let's go back in the portal. Now, these are all the flows. So essentially, routing intent kind of opens up a lot of the third-party vendor integration, and Palo Alto, you just deploy it as a SaaS solution. Perfect. So let me go back in and see how this is still working. I did want to look at the Rulestack. So let's go open the Rulestack here. Salman, maybe you could talk about the Rulestack versus the three options that we had. I forgot the third option. There was a Panorama. Oh, Strata. If you could talk about that, maybe when would you pick which one?
Yeah, so there are three options right now. The first one is the Rulestack. It's mainly for the customers who are just migrating or new to the cloud and who are just migrating their on-prem environment to cloud. They can always start with Rulestack. So Rulestacks, they can configure it from here, right from the Azure console. They can create rules. Rules mean they can allow or deny traffic based on IP addresses. They can also use application ID. So we have layer 7 application ID that customers can use to allow or deny traffic. All right, because most of the time application can use the same port and protocol. So it's really difficult for the customer to allow or deny traffic based on port and protocol. That's why we have the application ID where customers can allow or deny traffic, and then they can select which application they want to allow or deny. And then they can also, if you go to the security services, so let's cover here. So yeah, these are the different options. They can select the source. They can give up a certain IP or CIDR range. Then same thing for the destination where the traffic is going, whether it's
Where's
going to
the
a certain IP.
application ID?
I was
Yeah,
going to ask
application
that
ID
too.
is right there on granular control application, right there. Yeah.
Oh,
Yeah,
okay.
right here. Yeah. So if you do select, you will get a list of applications that customers can select from, like SSH or any other applications. They want to allow or deny SSH to certain applications.
Okay. Yeah, I see
Yeah.
it now.
So
It just
see
took a
a
few
ton of
seconds.
application, and we keep updating these applications. Yeah. So as you can see here, they want to just allow SSH connection to a certain application. They can do that. And then we also have port and protocols later on. If they want to use port and protocols, they can also do that. And then they can allow or deny traffic, whether they want to allow it and deny it. And then we also support TLS decryption, both inbound and outbound. So they can also enable it from here. As you can see here, the last option is TLS decryption. So they can enable or disable TLS decryption for inbound and outbound traffic. And then, as I mentioned before, we have integration with Key Vault. So if customer want to store their certificates for inbound and outbound decryption in Key Vault, they can. And then we will be able to use those certificates for decryption.
And also, Salman, so just for the benefit of our audience, when we pick these app ID, it is more intelligent than just picking the port itself, right?
Yes, it's more intelligent. It's a layer 7 capability that we offer it to the customer, right? So we go in and into the backend and see whether if it's really an SSH traffic or not. And then based on that, we allow deny traffic. Yeah.
Got it. Yeah.
App ID is irrespective of port and protocol. It will just, because sometimes customers or hackers can also use 22 for some other purposes. So they can use the port 22 for some other purposes, right? So when you allow 22, you can maybe be able to open doors for other applications. Maybe hackers are using 22 and they created some other malicious traffic, right? So SSH will only allow SSH. Irrespective of port, it will just, you will only be able to SSH.
Saman, one question that I have is, so if I have a custom app ID, or is that something I can add here?
Yeah. So with this local Rulestack, you can only select from the list that is available to you. Palo Alto Network keep updating this list. We keep adding more applications. But if you want to do more customization, you have some custom app and you want to add it to the list, then you have to either move to Panorama or SCM. In Panorama or SCM, you will get more customizing option to customize application and other part of this, the rules, right? So if you want to do customization, you have to move it to Panorama or SCM, where you will be able to add your own custom applications, and then you can use that to allow or deny traffic. Yeah.
Got it.
Thanks, Shruthi. Perfect. Thank you.
And then same thing with the application URL categories. We have a list of URL categories. Customers can also create their own list if they want. So for example, if they want to deny traffic to any cryptocurrency website, then they can just select cryptocurrency from here and then they can block these traffic, right? So the URL category is mainly for the egress traffic leaving their environment and going out to the internet. So then they can allow or deny traffic based on the URL categories. And customer can also create their own URL categories. There is an option for the customer, not here, but also in Panorama, where they can create custom URL categories. Yeah. So Panorama or SCM will give more features to the customers, more customization options, and there's some additional features that are available in Panorama. So more benefits if customer want to use Panorama, they'll get more benefits for SCM.
Got it. Do we have a link, and you can send it to me later as well, where you have a comparison between the 3 different options and what's not available maybe in the Rulestack?
Yeah, so we have a live community website, and we have a list over there that compares the Panorama, SCM, and the local Rulestack. And I will send it to you, and then you can share it with the audience.
Yeah, we'll put it in the description below. Yeah, so we'll do that.
Can we do a quick why would I use Strata versus Panorama in one line if I missed it?
Yeah, so the main difference is Panorama is basically an appliance that customer has to deploy. It's a VM. They can either deploy it in a cloud, or they can deploy it in an on-prem environment, right? And they have to manage it themselves. The Strata is more of a cloud platform. We manage it for the customer. They can just log into the Strata manager, and then they can go and create policies. And then there's also some feature set that are available in SCM, not in Panorama. So yeah, so it's a cloud-based platform. It's available on cloud. Customer can just log in and create policies, and they'll get full visibility into different platforms. Yeah.
So do you see customers using both Panorama and Strata together?
Not really. Most of the customers are either using Panorama or SCM. Yeah.
Or Strata. Okay. Okay.
Yeah, slowly a lot of customers are moving to Strata Cloud Manager. Yeah. It's the ease of use, right? They do not have to manage another appliance. They can just go and log into the Strata Cloud Manager and start deploying policies and managing all their platforms.
And it can go across clouds, is what I mean.
Yes.
Okay.
They can manage appliances running in different clouds and also in their on-prem environment.
So is it sitting in a VNET, or will it be all SaaS?
Oh, the Strata Cloud Manager is all SaaS. It's running somewhere else. Yeah, it's not in customer environment. It's managed by Palo Alto Network, right? So it's a SaaS service. Yeah.
The only way I'm accessing is it through a public IP, or is it some kind of integration?
It's a link. It's some link. Yeah.
Okay.
Strata Cloud Manager link. Yeah.
Got it.
Thanks, Shruti. Great discussions. Yeah, Salman, I think that it does look like Strata would be kind of the go forward direction, given it's all cloud-based, right?
Yeah. So a lot of NetSec customers, their option is either Panorama or SCM. Yeah.
Mm-hmm. So, and you were earlier going to talk about the security services as well. I think this is the one, right?
Yeah. Correct. This is the one. So we offer different security services that customers can enable or disable from here. For example, the vulnerability protection, anti-spyware, antivirus, file blocking, and then here's also the URL filtering, advanced URL filtering security services that we offer it to the customers. So over here, you can see there's no option to customize, right? We already configure based on the best practices. So either they can enable or disable it and use these best practices, the profile based on best practices. But if they want to, same thing as with app ID, right? If they want to do customization, then they have to use either Panorama or SCM.
Got it.
Yeah, and these are all add-ons. So whenever they enable it, they will get charged. If they disable it, then they will not get charged for these security services.
And remind me again, the billing happens through Azure, or is it separate billing?
Oh, same thing, pay as you go. If they're using pay as you go model, then it will bill through Azure. If they're using credits, then we will use credit for these security services also. Yeah.
Okay, and let's just run through.
Yeah, these are the different objects they can create. For example, if they can create prefix list and use them for source and destination. We also have FQDN list. If they want to allow or deny traffic to certain FQDN, they can just create a list and use this list as a destination in their rules. And then certificate is for the inbound and outbound decryptions. Customers can bring their own certificates, and then they can store in Key Vault, and we will be able to access that from Key Vaults. Yeah, these are the different options for the Rulestack.
Got it. Yeah, no, pretty, looks like a lot has gone in since the last time I looked at it.
And then I'll give you a demo later too, right? For the SCM, so you can see the difference. What's the main difference is. I'll see you some customization option in SCM.
Sure, yeah, that'd be great. So let's go see if looks like the firewall deployment is complete.
Yeah.
So we'll go into the resource group, and you can see that it has deployed the two public IP, one for the NAT, one for the firewall itself, the outside interface, and then I shouldn't say the outside interface, but it probably lands on the load balancer, right?
Yeah, that's
Salman?
correct. The public IP is basically the load balancer, public load balancer IP, correct?
Yeah. And then this is the Rulestack, and this is the firewall. So let's go to the firewall. We'll make quick observations. This is the public IP, and this is the private IP. Private IP, this one comes from, if you remember, if you go in the vHub, this is the address space that's coming from here. Okay. And so it got an IP from there. And then anything else on this screen, Salman, before we go to the networking and the NAT?
Yeah, I think the main thing is, yeah, let's go to the networking and NAT. Yeah, nothing else is on this screen yet.
Yeah, so in the networking and NAT, you can see it's associated with East US 2. This is the SNAT IP. This is the public IP, and this is the SNAT IP, right?
Yeah, and then we can configure different DNet rules here too.
DNAT rule, yeah, we'll set that all up. Okay. So now with that knowledge, let's go, and then the rule should be the LRS that we have. Okay, so this is on the NGFW side. Let's go and look at it on the vHub side. So if you're in the vWAN, we will go into the vHub where it's deployed. And now if you go into the SaaS solution, you can see that the firewall is deployed over here. The NGFW is deployed over here. And if you click here, it takes you right to the same place that we were before. Okay. I will also show you one more thing that I missed in the vWAN. So let's go back there. Here, I want to show you the VNET connection where my spoke is. Okay, so I have two VNets, and the VM that I am using to run the test is connected to this spoke VNet. Okay, spoke 1 VNet. We can make some observation. So this is the spoke VM that I have, and it is if you look at the effective routes on the NIC, we'll compare it before and after. So right now my default route is internet, and then we'll see how it looks like after we steer the traffic through the NGFW. So with that, let's go ahead and steer all the traffic through the SaaS solution. So now you can see they're both appearing here. Okay, cool. So anything else on this screen before we hit save?
No, I think that's the only thing the customer needs to configure here. Just point it to the SaaS solution. Correct.
Yeah, so Man, I recently worked with a customer where they did use these additional prefixes. So they were using public IP range within their network. And just for the benefit of the audience, in addition to setting it up here, we also have to do it on the
firewall resource side. Yeah, we can show it. Once it's done, we can go to the firewall resource and show it where they need to configure in the in the networking section, where we configure the DNet and SNet. There's an option there they can enable it. Yeah, if you go to networking and NAT, planning to use any public address as a private, then they can just put that prefix range. Scroll up. Just very similar to what we did on the vWAN upside. So you can enable
and
it
that
here,
has
and then
to match, right? That has
correct.
to match.
That has to
yes.
match. Correct.
Yeah. And here, this is the private source net. So you could also source net the private traffic.
Yeah, correct.
Okay, I haven't tested this. Interesting. Okay.
Yeah.
Okay, and so we'll go ahead and hit save. This does take a few minutes. All right. So let me jump onto the VM while this is saving.
I think it's done.
Oh, it's done. Okay,
Yeah.
perfect. Good timing. So now let's refresh the routing table over here, effective routes over here. And as you can see, with routing intent, the RFC 1918 routes got added, and then the default route is now pointing to the 61.228 IP, which is the private IP that we saw. So this is looking good. So again, this is the 61.228. Okay. Let me now jump on the VM and we will run a few tests. So my VM is in the same VNet that I showed you earlier, and it is already connected to the vHub. So let's go ahead and run curl if config.me, and you can see that it is indeed egressing using the 52.38 IP. Go check that the IP matches, and it indeed matches the SNet IP. Matches what we saw when we reached out from the VM. So that's that. Let's do a few more tests. We'll just do curl. We'll see if we have Google. Yahoo doesn't seem to be working. That does look like it's working, and then we'll run a ping. So ping is not working. That's expected?
Yeah, that's expected, Holly. Yes, because behind the scenes, these firewall, they're still using the public load balancer. And the public load balancer only can handle TCP and UDP. It doesn't handle other protocols like ICMP.
Ah, got it. Yeah. So it's behind the scene. It is still the sandwich design, so to speak, right?
That's correct.
Okay, awesome. Thanks, Daniel. Yeah, so we now have the outbound connectivity. So Salman, you mentioned we should turn on logging, right? So I'm not too familiar with it. So let's see. Maybe Daniel, you know how the settings are in the log analytics, right? So we can maybe you could walk me through it. So we go to
usually when you set up the log analytics, the firewall to send the logs to the log analytics, and you get to the first screen. Usually that first screen is just like a sample of built-in queries. In our case, because we're carrying the Palo Alto, we don't have a built-in sample, so we can close it. And what you can do on the top left, it's select a table, and if you go to the custom logs, you're going to be able to see the actual entry for the Palo Alto.
Nice. Thank you, Daniel.
And from that, you can do all the coastal query that you want to in order to plot properly the information that you need.
Okay, so where is the Custo query now?
So the Custo query, you just go to the top right and drop down. You have the KQL mode, and in the KQL mode, you can now add your specific query if you want to filter out specific information from the because of what you see below is the raw logging, and you can build your own Custo query to extract the information that you need.
And what is this fluent bit under CL?
Because that's the custom table, right?
I see.
And for example, if you want to do a query, for example, to filter out a specific, you can do like pipe. You can just type like under the table name. You can just hit enter, and you can start to do your own query. So if you do like a pipe, and it's gonna auto, you can have like
Okay,
autocomplete, where in this case you build your query where, for example, identity underscore s, and you can filter all the traffic that decryption, right? If you want to.
I see.
So
I got it. Yeah, I was confused by this naming. So this is actually the table.
Yeah, you have to have the table in
Okay.
order to build the query down below. Yeah, when you
Okay.
want to filter out.
And this is what they named it. Palo Alto named it to be Fluent Bit Unders. Okay,
That's correct.
good. Perfect. Thank you for showing that. So that was good. So now we can just do a quick test on inbound, and then we will move on to our next section of the presentation. So anything else for outbound or anything else before we go to inbound?
No, I
Okay.
think that's it for the outbound. Correct.
So what we'll do is let's just grab the IP is 10.1.1.4, and here I'll just kick off a simple Python 3-m http.server. We'll run it on port 8000. Okay, so it's listening, and we'll go on the firewall, and we'll set up the net. So we'll call it DNet to spoke 1. We'll call it, we'll use the public IP, we'll call it 8000, and then it was, what was it, 10.1.1. Oops. 4, and then we'll call it 8000. Okay, so let me just double check the IP. Okay. So we'll add the DNet, and then we'll hit save. So looks like this is saved. So let's go and test it from a machine outside, and we will hit this public IP on 8000, and it should reach the VM. So here I am, and I have, yep, so it is indeed getting hello world, which is a little index.html that I have on this one. Let's go here, and we can also see. Now this to me is interesting. On the VM itself, we see the source IP as 61.231. So is this the IP of the internal interface of the firewall also doing the SNAT?
Yeah, correct.
So, and just for completeness, I'll just show you that I think I have an index.html that just says hello world. Okay, so that's how this is working. Anything else that we want to show other than what we've already shown?
Yeah, these are the two. I mean, the north-south is one, and then the east-west also. I mean, for east-west, there is no need to configure DNet or SourceNet, right? It's just between VNet to VNet or from on-prem to cloud networks. Yeah. So by default, once you enable the private traffic in the routing intent and policies, then yeah, firewall will be able to inspect any VNet to VNet traffic or any traffic coming from on-prem to cloud.
Right. So the private traffic will enable this or on-prem too. Yeah. So what we tested was more internet we tested, and then we tested this DNet to the firewall, right? This user. But yeah, I do have a VM in the spoke. What we can do is it's not turned on. So in spoke, the other spoke that is connected to the vHub. So we could just, for completeness, I can go ahead and turn on that one. So here I have a VM in another spoke. It is 10.2.1.4, and we could do the same thing. Let's go to spoke 1 here, and we'll again kick off this one, and then we should be able to hit 10.1.1.4 on port 8000 from this one. So that one is the private traffic spoke to spoke or VNet to VNet. So we have covered all the flows, and I did want to share our official Azure documentation where we talk about exactly all the use cases that we tested today end to end. So basically we tested, if for east-west we did VNet to VNet, we didn't go across the hub to a different hub, and then north-south we tested from VNet going to the internet, we tested DNet. So this is a good documentation for all the standard use cases. Later in the video, we're going to, the SME presentation will show you some complex scenarios as well. So with that, I think one more, yeah. So this is Apollo's documentation for Cloud NGFW for vWAN, and this has all the details here as well. So I'll share both these links. Anything else before I turn it over to you, Salman?
Yeah, so these are the resources available on our side that talks about different traffic flows, and also we have deployment guides also available on our live community page. We can also put the link in the description later, Nihali, for our live community page. Yeah, there are a lot of videos there, and also a link to our deployment guides that customers can use.
Awesome, thank you. Yeah, so when you are ready, we're looking forward to the Strata demo.
Okay. Yeah, let me share my screen 1 second. So let's take a look at the SCM, how SCM works. So whenever you go and deploy the resource from Azure console and you go to the security policy section, you have 3 options there. You can either do local Rulestack, or for the NetSec customers, they can either select Panorama to manage the policy or SCM. So once you create the firewall resource and select SCM as policy manager, then your firewall resource will show up. This is Strata Cloud Manager. And once you deploy the resource will show up in Strata Cloud Manager in the device. If you go to the NGFW, in the workflow section, under NGFW section, NGFW setup section, you will be able to see your new firewall resource. As you can see, it's showing me the name and the cloud provider where this resource is running and the region. By default, all the firewall resource will show up in all firewall folder, but customer, as an option, customer will get an option. They can create multiple folders. So folder is basically, if they want to apply a certain policies to a bunch of firewalls, they can create folders. For example, if they have 5 resources in production environment, then they can create a folder named production and move all their resources under that folder, so that they can apply policies to that particular folder instead of applying one by one to all the firewalls. So they can go and create folders. I can create a production folder here. And then later on, I will be able to move my firewall in this particular production folder. If I go here, go to device management, go to folder management, I can easily move this firewall resource to a production folder, as you can see here. So my direction is, this firewall now is under production folder, so I can add more firewalls under this production folder, and then I can apply one set of policies to all these firewall resources. So that's where the folder concepts comes into picture. And then after that, once my firewall resource is up and running, I can go to manage section and go to configuration. And then under NGFW and Prisma section, I will be able to create policies and apply those policies to my firewall resource. So configuration scope, I can select my production folder where my firewall resource is right now. And then over here, you'll see we have different options. We have security services. Customers can go ahead and create security policies. If I want to create a policies, I can go to security policy section. And then over here, I can add a rule. I can select my zones, whether it's coming from private zone. So any traffic coming from RFC 1918, we tag it as a private zone, and any traffic coming from internet, we tag it as a public zone. So you can create policies, let traffic going from private to private zone if you want to allow or deny, and then anything going from private to public zone. And same thing here, just like we saw in local Rulestack in Azure console, you will be able to create IP addresses. You can create a group of CIDRs or group of IP addresses, and you can use them as source and destination. Same thing here for destinations. And then, and I think during the local Rulestack section, we covered the application part. So if you customers want to allow deny traffic based on applications, they can select the application from the list. And then in SCM, there is also an option if customer want to create a new application. As you can see here, they can do customization here and then say create new. And then they can also create a new application and then use it in their policies. For outbound traffic going out to internet to any particular URL, they can also allow or deny that traffic. So we also have a URL category option. And then I can select any URL category that I want to allow or deny. Different options here to select from. Social networking, if anyone want to block any traffic going out to social networking websites, they can select that and deny the traffic.
So quick question here, Salman. So
sure.
This feature set is at par with Panorama. So all the features that you get in Panorama are available, or is there differences between this and Panorama?
There are a few features that are available in Panorama and are not yet available in SCM. They will be available in future, but I think 80 to 90% it's in par with Panorama. Yes.
Got it.
And then, as I mentioned before, we have a list that compare feature set between local Rulestack, Panorama, and SCM, and we can share it with the audience later.
Sure. Yeah, that would be good.
So as you can see here, there are more options to customize your policies in SCM as compared to local Rulestack. You can create more applications, customize applications if you want. And then also same thing with the security services, right? You can either use best practices, or you can also customize profiles for different CDSS services and use them in policies. So that's how you can create a basic policies. But we have different options to customize. For example, the CDSS services, customers can create profile groups. Profile group is basically a collection of security services. If we have a customer that want to use wildfire or advanced URL filtering or advanced threat prevention, they can create a profile group and add these services into that particular profile group and use that profile group in the policies. So for example, you can create a new profile group, say new prod profile, and then you can select the security services that you want to use. I want to use anti-spyware, vulnerability protection profile. I can enable wildfire if I want to, DNS security. And then this is my one profile group that I can create. And then if I go back to my security policies, I can use that particular profile group in my security policy. So if I go here, I will be able to see this new prod profile here, and then I can use this prod profile in my security policies. So these are the different options for security services. And then customers can also create objects. For example, they can create address group. If you have a bunch of CIDR range, you can create a CIDR groups or address group and use these address group in your policies as a source and destination. And then application, as I mentioned before, now customers can create their own applications here if they're using some custom applications. they can add them here, and then they can use them in policy to allow deny traffic to those particular applications. This customization option is not available in Azure Console. This is only available in either Panorama or SCM. So these are the different objects, the application, address, and then certificate manager. If they're planning to use inbound and outbound traffic, they can bring their own certificates and use these certificates in the policies for inbound and outbound decryptions. So once they create the policies, they can go ahead and push that policy to to the firewall resource. So let's go ahead and create a policy, and we can say that allow outbound connection to internet. And then we can select any zone, from zone, any zone to any zone. For right now, just say any to any. And then in the application section, we can say that we only want to allow web browsing. So we can select that from the application section. And then if you want to allow traffic to any particular URL category, you can also do that. So over here that, okay, I only want to allow access to AI code assistant websites. And then you can select, okay, I want to allow deny traffic, I want to allow traffic. And then I can select the profile group that I just created, new profile, and say save. So this is my policy. And then if I want to push that policy to my resource, I can say, okay, push config. And then say new policy here. And then I say push. Now I'm just pushing the policy that I just created to the firewall resource.
And you can push it to multiple firewalls and across cloud.
Yes, you can. Yeah. So if you have multiple firewall resources here running in different cloud, as I mentioned before, you can just put them in under one folder. And then you can just go ahead and say, okay, I want to push, and then just select this folder. So as you can see here, I have a production folder, and I have multiple firewalls here, maybe one running in Azure, one in GCP or any other cloud. And then this policy, I will be able to push them to all the firewalls in different cloud or also in on-prem network. Yeah.
Very cool.
And also, if your customers want to see the logs, like traffic log, threat logs, then we have an incident and alert section. And in this section, we have log viewer. So over here, customers will be able to see all the logs, all the traffic that is going through the firewall. And then they can also do filtering. So if they want to do filtering by source address, they can just select from here, okay, I want to filter any traffic coming from this source going through the firewall. So any traffic going through the firewall from this source, it will show up here. As you can see here, this source is trying to reach different websites or different public addresses. And all of this traffic is going through the firewall. So this is my regular firewall traffic. I can also see threat. If my firewall blocked anything, then I will also be able to see it here, any threat traffic. I don't have any threat right now, but if any threat traffic is going through the firewall, then we'll also be able to see that. So let's clear our filter and see if we can see anything. Okay, yeah. So we have a lot of threats that are detected and blocked by our firewall. So you will be able to see that in firewall and threat section. And then we also have command center. Command center will give you full visibility into all the different platforms that you are managing through SCM. Right now in this SCM, I only have one resource, firewall resource, and you can see that this resource is trying to reach. There's some traffic going to internet through this resource, and you can see all the different applications here. So you'll get full visibility into what kind of traffic is going through the firewall. So all the VMs that are running in Azure are trying to reach. I think I have a couple of Microsoft Windows VMs, and they're trying to reach MS updates and other different websites. So you can see there, I can see all the traffic that is going through the firewall. And then I also have threat section. So if firewall block anything, I will be able to see that. As you can see here, threat prevention, firewall blocked blocked two malicious traffic in past 3 hours. And then if I want to get more details, I can click on vulnerability section, and then I'll be able to get more details about what kind of traffic was blocked by the firewalls. So in case customers has to adjust or change the policy, they can do that. If something is not blocked by the firewall or is showing as an alert, then customer can always go back and then update the policies to block that particular threat. So that's the benefit of SCM. You can manage not only the Cloud NGFW resource, but also any other hardware or software firewall. And then you can just create one policies and will be able to apply that policies to different platform on hardware firewall or software firewall from SCM. And then they will get full visibility into the traffic, what's going on with the firewall, what kind of traffic is going through the firewall, how many threats were blocked. And then they will also get a recommendation from SCM. If something is not right, they will get recommendation based on the best practices, and then they can make changes based on those best practices. Any question, Nehali?
Yeah, so let's say that when we deployed the firewall, like earlier in the demo, when I deployed the firewall, I picked Rulestack, local Rulestack.
Mm-hmm.
Is it possible to change it after, or do you have to do it at decide the security policy at the beginning?
Yeah, right now it's not possible to change the policy management. If you selected Rulestack, then you cannot change it to Panorama or SCM. What you have to do is you have to create a new firewall and then select SCM or Panorama as a policy manager. Yeah.
I see. And so what, maybe I missed it in the demo, but if I did select SCM,
Mm-hmm.
what does it need from the Azure side? So it prompts me for, I just opened up a window and it prompts me for SCM tenant information. And where would I find that?
Yeah, so basically you need a SCM Essential or SCM Pro tenant. You can, customers can reach out to the Palo Alto network reps, and they will be able to give them access to, I think if it's a new customer, they can always start with SCM Essential. And then the good thing is they can start with SCM Essential, and then they can use that to deploy a firewall resource. And then as soon as they deploy a firewall resource, the SCM Essential will convert into SCM Pro, which is a Pro version, and they will get more feature set in SCM Pro. So the one right now I'm using it SCM Pro. So they need to reach out to a sales rep, and they will be able to give them access to the SCM.
Yeah. I see. So the workflow is before deploying the firewall, that should all be ready, because in the drop down, like in my subscription, I don't see anything. So the workflow would be, once that's enabled, I'll see a tenant, and then how does it tie with this Panorama, with this SCM? I didn't understand that part. Is there like a key, or do you have
that's
to
a good question. Yeah, let me cover that part once. Let me share my other screen. And so whenever you deploy a Cloud NGFW resource, you need to link it to a Palo Alto Networks customer support portal account, CSP account. Right. So if I go click here, let's start with the Rulestack first. So if I go to the Cloud NGFW Rulestack, right? So if it's a brand new customer, what they need to do is they go and subscribe to the Cloud NGFW service from the marketplace. And after that, what they can do is they can go and come here and then just create a Rulestack. Just maybe a test Rulestack if they want. we need to create a rule stack so that we can tie this this Azure tenant to a Palo Alto network support account, right? So the first thing they need to do is just create a rule stack. They do not need to create any policy or anything. Just create a rule stack, and once the rule stack is up and running, let's wait for 1 minute. Then we can once it's done, I'll show you the next step. So once they create a rule stack, they need to go and register that that tenant to our CSP portal. So let's go here, rule stack. So this is my rule stack. Let's say this is the first rule stack they have created. Go to the support and troubleshooting and click on new support request.
Okay.
Because I'm already registered to a CSP portal. That's why my CSP account is showing up here. If they're a brand new customer, then there will be a link here that register this tenant to a CSP portal. Once they click on that, it will walk them through the whole process of creating a CSP account. Ask them their email address, first and last name, the company information. And for the new customer, it will go ahead and create a customer support portal account for Palo Alto Networks. And after that, they will get a support account ID or number here. So that's the first step they need to do. After that, they can reach out to or if they're already working with a sales rep can give them access to SCM. And they have to make sure that their SCM is also tied to the same support account. Because once they spin up a SCM, it will ask them for a support portal account number. They have to make sure that they give the same account number when they spin up SCM. So that's how they are tied together using the Palo Alto Network support account.
I
So
see.
that's how we get the information. So if I go here and then I say, okay, I want to create a new resource. And then if I go to my security policy section and go to SCM, so any SCM that is part of that support portal account will show up here. You will see a lot of SCMs here in the list because they're all part of the same CSP portal. If you only have one, then that's the only one will show up here. So the key is the support portal account. We have to make sure that this Azure tenant and your SCM, they are both tied to the same customer support portal account. If they are tied to the same support portal, then your SCM will automatically show up here. Customer don't need to do anything else. Yeah.
Got it.
Yeah.
So there must be
an.
Oh, sorry. Go ahead.
No, I was just saying the key is the support portal account. Yeah.
Yeah. So there must be like an onboarding doc or something that we can share for this, right? Yeah.
Yeah, we can share how to onboard SCM, what are things that are required. We can share with them.
Okay, great. Thank you. Awesome demo. Thank you for showing us this. So that brings us to the next part of our session. We have the SME session first with Maze and then with Shruthi. Over to you, Maze.
You guys let me know when you start seeing my screen.
We do.
Okay. So today in this first thing I prepared, or let's say scenario I prepared, I just wanted to highlight some configuration that I've seen customers are missing, and it was causing confusion. Like, yeah, we have done what we should be doing, but however, the results are unexpected, let's say. So this scenario here, what I'm using virtual WAN. Virtual WAN is using routing intent, where I have a firewall inside the vHub, and I enabled routing intent feature. What routing intent does, it lets you inspect private traffic or internet traffic or both. So what I've seen when customer enable private traffic inspection, when they have firewall, it could be Palo Alto firewall, it could be Checkpoint firewall, Fortinet, or recently Cisco FTD. These are the supported firewall inside the vHub. So once they enable routing intent for private traffic inspection, what happens is all spoke traffic or anything from spoke 1, let's say, to spoke 2, spoke 1 to on-prem, spoke 1 all the way to the other region to spoke 3 or spoke 4 will have to go first through the firewall. It goes to the firewall in the local hub or vHub, and then goes to the firewall in the other vHub when we are talking about inter-region inspection. The main thing I've seen some customer falling into is that private endpoint traffic inspection starts failing, or they start reaching to anything enabled by a private endpoint from on-prem. And why is that? So all we know when we configure private endpoint for, let's say, SQL database or any PaaS service, right? This will give us a private IP with /32. What does that do in vWAN? That means the virtual network gateway in the vHub will have /32 injected here. So when traffic comes from on-prem, goes directly from the virtual network gateway to the private endpoint. However, the private endpoint for return traffic, it has to go through the firewall because it knows nothing beside RFC 1918 prefixes injected in this spoke. It won't have like exact prefixes for anything for on-prem or for within the same region or inter-region. So it will go through the firewall. And of course, that means the traffic is asymmetric and the traffic will start failing. For that, we mentioned in our docs, if you have a private endpoint, you have to enable what we called network policy at the private endpoint subnet. In this case, the private endpoint, the /32 that will be injected on the virtual network gateway won't be injected anymore. And the traffic will just flow from the on-prem to the firewall, to the PE, back to the firewall. So that's something I've seen customer like, okay, we have an outage. We turned private inspection on. So that's one thing. The other thing I want to mention today is public prefix. Sometimes customers are using public prefixes and they want to treat it as like it's a private traffic. So when, let's say, spoke 1 wants to communicate with a public prefix that's on the on-prem, we want the firewall to treat it as a private traffic. So if the destination is public prefix, it shouldn't go to the internet. It should go back to on-prem. So we have in the portal, we have a configuration in the routing intent blade to say, hey, can you define what the private prefixes are beside the RFC 1918? So the customer should go here and define this public on-prem prefix. And it depends on your firewall vendor. You need to know where is the extra configuration should be done. For example, for Azure Firewall, you need to do extra step on the Azure Firewall to say, hey, this on-prem or public prefixes should be SNAT range, meaning I'm going to this destination public prefix that's on-prem, I shouldn't SNAT and go out to the internet. For Palo Alto NGFW inside the vHub, you will have to do it also in networking and NAT section here. You have to add them. So it depends on your vendor, Checkpoint, Fortinet, Cisco FTD, you have to make sure that you're adding this extra step beside what you have configured on the routing intent blade. Last thing, which is actually this applies for either you have firewalls inside the vHub or you have firewalls anywhere. It doesn't have to do anything with the firewalls configuration. It is just like a use case I want to go over. So as you see here, I have connectivity to on-prem from each region, right, over express route circuit. So I have this express route connect me to from region 1 to on-prem, and also I have from region 2 to on-prem. We see this deployment like this, but we also see the customer most likely will do what we called a bow tie deployment for express routes, meaning if, let's say, for any reason, the circuit is down, right, I will have this connection here to go over my inter-region circuit. Now with vWAN, you don't really have to do this bow tie configuration because with vWAN, it's like any-to-any, meaning if this circuit is down, spoke 1, if it want to communicate with on-premise still, and of course, on-prem has to advertise the prefixes unless they are the same over both circuits, it will go like this by default, unlike in hub and spoke. But sometimes customer will be like, no, I don't want to like going from region 1 to region 2 and then go back to the down to the circuit, because there will be some cost for inter-region data processing. So they will just do this bow tie type of connectivity. When this happens, when you have this bow tie connectivity like this, even inter-region traffic, let's say spoke 3 to spoke 1 or spoke 2 will go over the express route circuit, not really inter-region within Azure backbone, let's say. And the reason for that is there is a configuration in the vHub called HRP, which is Hub Route Preference. This one by default is set as express route circuit. So when I have the route learned from express route circuit and also learned over the vHub inter-region, and because I have set this as express route circuit, I will prefer express route circuit. So you need to make sure once you have the bow tie configuration, you need to change this into actually AS path. With AS path, it will make sure that you will get the optimized routing. Any question here? Maybe something not clear?
Oh, that was great, Mace.
Okay.
Just wanted to emphasize on your previous scenario about the private endpoint that the setting is buried at the subnet level.
Right.
So that was something that I had observed, and the same is true for VPN as well, right? For
Correct.
VPN express route. Okay.
Correct. Yes. Okay, I will move to the other scenario here, which is I had many customers asking for default route option when I have routing intent enabled. So today, as I mentioned, when we have routing intent, that means you can inspect private traffic as well as internet traffic. So by default, I can enable inspecting internet traffic. What does that do? That means my spokes, any spoke needs to talk to the internet, it will go to the local firewall and go out to the internet, which is fine. And most of the customer like it. However, there are some use cases where customer will be like, no, actually, I don't want to use my firewall that's in Azure to inspect the traffic before it goes to the internet. I need to force the traffic to go first to on-prem, get inspected here, and then go out to the internet. Or the other use case is like, okay, I have my firewall inside the vHub. However, this is not the firewall I want to use to inspect the traffic. For example, some customer will be using Azure firewall, let's say, to inspect east-west traffic. However, they want to use like Cisco ASA for the internet traffic. And why Cisco ASA? They cannot have it in the vHub because it's not one of the supported firewalls, let's say, inside the vHub. Or let's say they already here using, for example, Palo Alto, this firewall. As of today, you cannot combine two MVAs together at the vHub. So you cannot have, let's say, Palo that you are using for east-west traffic, but you chose to use Checkpoint, let's say, for internet traffic. That you cannot combine within the same vHub. So how can we design if the customer have those requirements? Let's look at the first requirement when the forced tunneling to on-prem is a must. So the only thing we can do today, because forced tunneling with routing intent and where the firewall is inside the vHub is not supported as of today, the only thing you can do is that you push the firewalls that we had in the vHub before, we push them to transit VNet. This transit VNet will be connected to the vHubs, and all your spokes where your workload is at will be pushed out of that transit VNet. You will have VNet peerings, you will have VNet connections from the transit VNet where you have the firewall, and basically you will be configuring UDRs on those spokes, because as of now, they have no clue what's behind this firewall. So you need to define, hey, anything I want to communicate with outside my spoke, go to the firewall. Firewall is learning on-prem, And at the same time, on the vHub, I have also to define those spokes. Now, for on-prem to be aware where those spokes are. And for that, you either do it statically by going to the default route table in the vHub and say, hey, my summary spokes resides here, or the exact spokes. Or you can do a BGP peering if your firewall support BGP. And in this case, when you're defining those routes here or prefixes for the spokes, that means now on-prems are aware of it, as well as the other region. So traffic will go like this if I'm going to the inter-region. And traffic will go like this if I'm going to the internet, and also on-prem. So that's the only workaround today if you want to have forced tunneling to on-prem for your workload in Azure while using vWAN. The other scenario is, okay, my customer is not looking for forced tunneling. However, for the reasons I mentioned earlier, you are using one firewall for east-west and another one you want to use another or different flavor for internet traffic. And as I mentioned, like maybe the MVA is not supported inside the vHub, or you cannot combine two MVAs. Maybe you have like Palo and Checkpoint, for example. So what you can do in that case, and you want to use this MVA, the other one of your choice, to do the internet egress, you will have it in a VNet connected to the vHub directly, just like the idea of transit VNet, but here the spokes are still connected to the vHub. You will add another peerings from those spokes to the local MVA or your local firewall, and also you'll use UDRs to point the traffic here. Now I want to mention, sorry, I want to mention that some customer try to trick the limitation we have today with if the vHub have a firewall. As I mentioned earlier, 0, 0 is not supported. Forced tunneling is not supported, meaning I cannot send 0, 0 this way, or I cannot send it on-prem. They were trying to trick or work around it by either using static route propagation, which is, let's say they have an MVA here, and on this connection, they say, hey, 0, 0 lives here, but that doesn't work. They also tried like to influence the firewall by using BGP peering to the route server inside the vHub and saying, actually 0, 0 lives here. As I said, that's not supported, so it's not going to work. They also tried to influence it in other way, like, okay, let me, instead of 0, 0, let me advertise something more specific, right, than 0, 0. So, okay, firewall will have its own 0, 0, but I will have more specific. So for sure, traffic will be attracted here. But even if that works, that will break some control plane you have on the firewalls and other things on the gateway. So it's not recommended and is not supported. And on the other side, when you have a firewall inside the vHub, you cannot go to the default route table inside the vHub and configure a static route table. So there is no way today, let's say, to change that behavior of forced tunneling, either from MVA inside Azure or from on-prem to be supported when you are using routing intent or firewall inside the vHub, let's say. So with this workaround, which I had multiple customers adopting it, again, you will have peering from the spokes, and you will just need to define a UDR 00 here to point everything to the MVA to have the traffic goes to the internet. So I think that's clear what the workaround would be for forced tunneling using MVA in Azure. Sorry, that's all I have today. So back to you, Nihali.
So Maze, just one question on that. Yeah, this scenario here, you have routing intent disabled here, right?
That's right, because yes, there is no firewall inside the vHub. So there is no need to use it. I mean, we can't even use it. There is no firewall here. So our firewall will be in transit VNet, and that's why we were able to send 0, 0 all the way to the firewalls here.
Okay, and on the last scenario, just to kind of emphasize, if you go back to the last scenario here, so Maze here, if you had a BGP endpoint in the vHub, you could still advertise specific prefixes, just not the default route, right?
Correct. Yeah. Any private prefix or public prefixes that's not 00, you can still influence it through the MVA.
Okay, great. Thank you.
Awesome presentation. Thanks, Mace. Over to you, Shruti.
So today, what I'm going to share is a specific design that I worked with one of my customers, and what were the challenges we faced, what to do and what not to do at all. So let's start. I'll just run through the design since Maze just walked through the multi-region. If you look at the overall vWAN setup, it is very similar. So let's just talk through this, right? So you have two vHubs, which are in different regions. Each vHub has spokes linked to it, and routing intent enabled with firewalls on each of the vHubs. Since I will be focusing on private routing, so let's just assume we have private traffic being routed through the firewall. It could be both, but for the sake of this scenario, let's just assume private routing is through the firewall. Now, what we additionally have is two different on-premises, which is linked through its own express route circuit. Now, customer also has AVS in both the regions, which are linked to the vHubs for spokes connectivity back to the AVS, and for on-prem connectivity back to the AVS, they have global reach. At the time we set it up, there was no requirement for on-premises connectivity cross region. So on-prem in region 1 did not need connectivity to AVS in region 2. So just to highlight that there is no connectivity back. So this is a high level about how the setup is. I want to also call out a few route map scenarios. So route map is our new feature, fairly new feature that went GA recently. So in the same architecture, you could utilize route maps for multiple scenarios. But before this, I just want to take a pause. If there are any questions around the architecture, let me know before we move on.
Just a quick question, Shruti. So far now, there
Yes,
isn't any connection between on-prem on the left and the AVS region 2, correct?
That's correct. On the left and
Okay.
AVS region too. Absolutely. Okay, if nothing else, let's talk about the route map scenarios. So what we get very often is, as you can see, we have different vHubs, and since it is a virtual WAN connection, which setup, which is nothing but a full mesh. So the express route here, both, right, ER1 and ER2, both will receive prefixes spoke 1, spoke 2, and also spoke 3 and spoke 4, all the way to the on-premises. So on-premises here will receive all the prefixes. Now, at that point, and eventually when on-premises receives the prefix, what it will see is all the prefixes with one single AS path, that is 12076. So when that happens, it might be challenging for them to distinguish which is from region 1, which is from region 2. So community tagging might be a very useful option for them to use. And we've got these requests a few times that, okay, I want to tag each of these virtual WAN spokes in different regions with its own community. So what you can do is you can assign route maps, which is on a connection level. So you can assign it to a connection on express route, all the way back to the on-prem, and assign communities, community tag for each of those prefixes. So region 1 could use a specific community tag, region 2 could be using a different community tag. This helps on-prem plan how they want to route traffic, differentiate traffic, filter if they wanted to. That's one use case. I'll pause here. Okay.
Yeah,
Any
I have
question?
a question. Yes,
Go ahead.
Shruti, I
Go
have a
ahead,
question.
Shruti.
So the community is used to identify resources or a given region. So where would you apply the roadmap to set the community on the express road connection to
On the
identify?
express. Yeah,
Okay.
it can be both. What you can do is you can attach, since it's connection level, you can attach it here and then reuse that community here for each spoke if you wanted to attach, and that just flows. Or the most optimal will be if you go ahead and put a community here. Okay, moving to a second use case. Let's talk about route maps. So anybody who's used AVS here or is familiar with Azure VMware solutions, you would know that it's not a single prefix that is advertised. There will be a bunch of prefixes that will be advertised. When that is advertised, it can be a little overwhelming. You'd want to summarize it, make it easier to manage. Or if you're concerned about hitting any kind of route limits, with, let's say, even vHubs have a limit of 10K routes. Overall, 10K routes overall from spokes everywhere together, max it can learn is 10K routes. So if there is any reason that you feel I want to summarize the prefixes that I'm learning, you can use route maps to do that. So you can put a route maps in the inbound direction, summarize those prefixes. When you do the summarization in this scenario, keep in mind you are doing the summarization. You will have to do the summarization on two connections, both AVS ER1 and also ER1. The reason is if you only summarize these prefixes coming out of AVS ER1, due to global reach, AVS prefix also gets advertised via GR all the way to the gateway. While it is a much longer prefix, it's the AS path length would be way longer than what is advertised via this. But since you modified, summarized it, you will have, since it'll all be based on longest prefix match, you will have a more specific route coming through this. And what you'll end up seeing is all your traffic to AVS will now go through ER1, global reach, and then back to AVS. So when you are doing summarization, specifically for AVS in this scenario, make sure you do it on both connections or use the same route maps. That's about the second scenario. Any questions?
This is good.
Okay, so let's move to the final scenario with route maps. It's what we've gotten very often as customers, they have a very restricted environment where they, let's say, are not able to do any prepend. So we get it very often, hey, I want to prepend the prefixes that you are advertising to us. Is this something I can do on Azure? Guess what? With route maps, you can. Add a connection route maps again in the outbound direction and make sure you do prepend on the prefixes that are advertised. You can match based on the prefixes or community and make sure they are prepended. But one thing that you'll have to keep in mind is when you are trying to prepend, you have to use a public ASN. You cannot use private ASN. And the explanation for that is it's twofold. One is if you try to prepend using a private ASN, express route, while the circuit does learn the prefix, it will strip off the private ASN when advertising to on-prem. So on-prem in both scenarios will only learn the prefix as with 12076, and whatever prepend you did, it's gone. So that's the first half of the explanation. Second is to avoid such scenarios where customers unknowingly, knowingly make this error. What has been done with route maps is that it won't even allow you to prepend using a private ASN. So you will not even be able to put that in the configuration. Today, you cannot use a private ASN for prepend in any direction for any connection, but that behavior might change. So for example, if you had a VPN connection, you might be able to prepend with a private AS, but be on a lookout for what that behavior would be when it would be changed. But for now, there is no private AS prepend that's possible with route maps. You can prepend with public AS. So that's about it for the route map scenarios. I'll take a pause here. Any questions?
No questions, but loved all the different use cases. Thank you, Shruti, for sharing those.
Thank you, Nihali. So let me
And
walk
you also
through.
have a blog about this, right? You've written a blog about this?
Not about the route maps, but
Okay.
in general about the AVS connections. Yes, we have a blog about it, which we can share.
Okay.
Okay, now the same customer, they have this implemented, working great. Then they had a new need that arose during this entire setup, like we discussed earlier, right? When we set this up, the requirement was there was no requirement for connectivity across from the on-premise to AVS in region 2. So it was this very default setup where they have connections from vHub to different to on-premises, but no connection from AVS to cross regions. The requirements changed because when they started, it was active standby kind of a setup. But as time progressed, they had a lot of active workloads running on both regions, which needed on-prem in both regions to have connectivity back to both AVS. So what was the solution for that? What we did? Let's discover that. So solution was pretty easy, right? It started with, hey, okay, you want connectivity from on-premises via Express Route 1 back all the way back to AVS in region 2. Just create a global reach connection. And that will enable the connectivity. Now you might ask, I already have vHubs, I already have all those connections there, both connected to the vHub, and we just spoke about full mesh. But with Express Route, keep in mind, they are not transitive by nature. And that is also the reason, even in the local region, I have to use global reach. So if you want two express routes to talk to each other, you need global reach, or let me put it this way, global reach is the most optimal path. You could use routing intent with some additional steps like talking to support and hairpinning all the traffic through the firewall. It's a possibility, but if we're looking for the most optimal path, that is through global reach. So like I said, solution was simple. We did global reach across crisscross. And when we did that, this enabled connectivity between cross-region on-prem and AVS. But it came with some side effects, some behavior that they'd have to modify. Now, if I just go back to my first earlier setup, I never spoke about hub routing preference. I never spoke about anything of that sort here. I think Maze did touch on hub routing preference earlier, but here I never spoke about it. The reason is we can just leave it as default and things would just work because there is no bow tie, there is none of those setups. So meaning in this scenario, spoke across regions will talk to each other through interhub. You don't have to modify anything. But the moment you do this setup, right, where you have enabled global reach, what would happen is your spoke prefixes. So let's take an example. We'll take the example of spoke 3. spoke 3 prefix will go to AVS ER2 and go all the way to ER1 and get to vHub1. So when that happens, if you have set your hub routing preference to default, you've not touched it, the default is ER. So if it is set to default, you will see an impact, which would be now the traffic, instead of taking the optimal path of interhub, it will take through, ER1, go all the way to ER2, AVS ER2, and then get to spoke 3. And we don't want that, right? We don't want that. Also keep in mind, that's not the only path. It could also go through this path. So multiple paths for, different pops, very unpredictable routing. So what you should and must do is you have to set the hub routing preference as AS path. When you do that, it will clearly look at the AS path length, which we will talk about in a little bit. But whenever the routes are advertised over global reach, learned via Express Route Gateway, we as in Microsoft does additional prepends, ensures that path is way longer than what is sent over hub to hub. And that's hence, when you set hub routing preference as AS path, spoke 1 and spoke 3 now know they are supposed to now talk to each other through interhub without going through the POPs or point of presence. Any questions? I'll take a pause here.
I just wanted to call out. So here you have the bow tie or crisscross using global reach, and when Maze had the one with the express route gateways, right?
That's correct. Maze had something like this. I mean, not exactly this, but yeah, the circuits were linked to both. But I do not have direct connectivity. I have not linked any circuit directly to the gateway. But this scenario also warrants AS path, even though there is no bow tie, just because how the routes will eventually be learned by the gateway.
Got it. Makes sense.
All right. Okay. So now I want to talk about a little bit about the flow that was noticed when we implemented this, right? So what happened is all the connections to its own region, on-prem, great, everything works, right? One question that came up or was noticed is how will spoke 1 communicate to AVS region 2? So let's talk a little bit about what the traffic flow would look like there. Here. So what you will observe, notice, or what will happen is spoke 1 to AVS region 2, the traffic would always traverse through express route. So meaning the traffic from spoke 1 to AVS 2 will go through ER1, then AVS ER2, and then would make it all the way to region 2. Now you would have a lot of questions in your mind. You made me set up hub routing preference as AS path. Why is this happening? Why is the path not through interhub? Why is it not going through interhub, then making it to AVS region 2? Let's understand a little bit about the routing and how prefixes are advertised. We will look at first what vHubs learn and forward path. Let's look at it that way. So AVS region 2 10200 prefix will be learned via express route all the way by the gateway. So meaning from AVS region 2, it makes it to AVS ER2, then to ER1, and then to the gateway. And if you recall, I said we do additional prepends for prefixes advertised over global reach towards the gateway. Why am I highlighting towards the gateway? Because the behavior is different towards on-prem. You will not see any of those prepends. You would just see, two prefixes, 12076 and your AVS ASN, but it's different when it is towards the gateway. So additional prepends are added, meaning the path would look something like this. 3 times 12076, and then your actual AVS ASN. This is how it would look on the vHub when it learns from the gateway. Now, while vHub also learns the routes from inter-hub. So AVS region 2 to the gateway, vHub 2, then to the firewall or vHub 1. So it does learn the route. When gateway learns the route first, let's break it into pieces. So when vHub 2 learns the route, what it learns is just, 12076, because this is not via global reach. This is a direct connection. So no additional 12076 that we saw here is added. So all we see is 2 ASNs. Great. This looks like a shorter path so far, but whenever there is an inter-hub route, meaning whenever the routes are traversing 2 vHubs, there are additional ASNs that is added. So in this case, 65520, 65520. So if you look at the ASN, 65520s, 12076, and AVS AS, like we saw from here. So these two plus additional ASN. Now, what happens? Which one will we have programmed? Because if you look at it, both have exact same ASN. So what is clear is AS path is not the tiebreaker here. Okay, so let me break it to you. It will, whenever there is a tie, when the ASNs look identical, express route always wins. So the route, inter-hub routes will never be programmed on the vHub, or the only route that is programmed, as long as your express route is up, is your route via the global reach path. Hence, the traffic from spoke 1 will go to ER1, then make it all the way to AVS region 2. So that's about the forward path. Okay, so now we know path from spoke 1 to region 2. How is the return traffic flowing? We know one path, but how is the return traffic flowing? How do we make sure the traffic is symmetric and now return is not going through interhub? Let's talk about that. So now let's take spoke 1 prefix. Spoke 1 prefix first is advertised to ER1. So ER1, all express route 1 circuit will see is 1010/24/65515. That's the only AS in the path. Now, what happens to, because this is a global reach connection, which is nothing but a VXLAN tunnel and a BGP running on top of it. It runs iBGP, which means no additional ASNs are added. So when AVS ER2 learns the routes, it learns is exactly the same AS path length, nothing changes. So we know now that first AVS ER2 learns spoke prefixes via ER1, AS path length 65515. Now what happens when spoke 1 prefix is learned via interhub? by the same circuit. So two things happen. One is, like we discussed, anytime the routes are advertised over interhub, additional ASN is added or prefix is prepended with this AS. So what you will notice is first, you will see 65520 twice on the vHub itself. Additionally, when the gateway advertises it down, it adds a 65515. So you will see I have grayed out all the paths that is not programmed. So you will see it has three ASNs. So AS path length is longer. So here the decision is made due to the AS path length, and GR path or global reach path is shorter, which is good in this scenario because it helps us maintain symmetry. So that's all about this scenario. And I have one more scenario to go over, but I would like to take a pause and ask if any questions.
So no questions, Shruti, but fantastic explanation. This is by far one of the best explanations I've seen for this pattern. And just curious, so there in this scenario, there is no way to leverage the interhub link, correct?
No, and that's what is my next scenario that I'm going to talk about, leveraging if customer wanted to leverage interhub.
Okay.
So what
Perfect.
Yeah. So what happens is a lot of the times we do get this request. In fact, I had my customer specifically ask, I want to, hey, now you guys have route maps. I said this was during when route maps was preview. Now you guys have route maps. So I want to use that. I want, for a number of reasons, right? I want the traffic to go through both firewalls because anything going to region 2, I want it to be inspected by the firewall and we have to. So I want it that way. He said, you have route maps now. I will go ahead and drop the AVS prefixes that is learned on the gateway. This will ensure that my vHub1 only has one path to get to AVS region 2. Great thought. It is a great thought that you go take the route maps, attach it to this connection, and then you say, hey, let's drop the AVS prefixes. When you do that, we have one has no other path to get to AVS region 2 other than vHub 2. So you definitely got what you wanted. But there is something that you missed. That is the return path. Now, what happens when AVS region 2 wants to send traffic back? Will it take this path or this path? We already discussed this, right? This path will be shorter. So what you have done is you have created asymmetric routing now, and your traffic will be dropped, right? So imagine AVS region 1 initiates some traffic to spoke 1, goes through this and comes back through this. Firewall has no idea what this traffic is, dropped. Now you might ask, okay, so why am I only dropping prefix in the inbound direction? Let me drop prefix in the outbound direction. The thing is, not. If you go ahead and drop prefixes in the outbound direction, what you would do is now even your on-prem will not learn your spoke prefixes, right? Because you are dropping it on a connection level. So if you drop it here, your on-prem won't learn either. Then you might ask, okay, I can't drop it, but can I prepend it, make it longer? Sure, you can prepend as long as you have public ASNs. Go ahead and prepend it. You might fix this flow. You might fix this flow where now it'll come here. It'll say, oh, this is a longer path for global reach that I'm getting, so I'm going to return this way. You fix that. But you might or you will break other paths. For example, since you did a prepend ER1, as we know now that spoke 3 prefixes or even spoke 1 prefixes will be learned through this path. Now, because you prepended this, ER1 will think, oh, the better path for me to get to spoke 1 is through vHub 2, which is not optimal at all. So on-prem will now go this path and get to spoke 1. So what I'm trying to get to is this is not a good use case for route maps at all. When you have GRs or crisscross connection here across AVS, do not rely on route maps to get you through the inter-hub connection. Continue to use the default behavior, which is using the single firewall in that region or whatever firewall you have in this region for inspection and allow the default routing to flow. Any kind of manipulation that you might try to do here might fix something but break something else. So you can still continue to use your route maps for other scenarios, what we discussed earlier, right? Summarization, community tagging, and also prepends towards on-prem maybe for other prefixes. Actually, I take that back. Careful with the prepends. But do not use route maps to modify this behavior. This will give you suboptimal routing and other issues. So that's about all the scenarios today. Anything you think I missed, Nihali, Cynthia, or Salman?
No, thank you. It was super clear and a lot of super useful information for me. Thank you.
Absolutely, couldn't agree more. Really fantastic scenario and very clear explanation, Shruti. One thing just wanted to call out that in all your scenarios, the firewalls could very well be the Palo Alto firewalls, right? So I just want to make sure this is applicable to all the Cloud NGFW scenarios.
Absolutely, it's applicable to all Palo scenarios or any firewalls that are inside the vHub.
Awesome.
Thank you so much, guys.
So that brings us to the last section of our presentation on Cloud NGFW with VNET based architecture.
So to keep the consistency in diagrams, I picked up this architecture from Palo Alto's official documentation. And so let's quickly walk through this one as well. So this one has a hub here and the 2 spokes. And you do need 2 subnets, private subnet and public subnet configured with proper delegation. And I'll show you that in the portal to kick off the Cloud NGFW. Okay, installation in the VNet design. So with this architecture in mind, let's go to the portal. So here I will show you, we'll create a new resource. We'll deploy the Cloud NGFW in a new resource group in the hub and spoke architecture. So we'll go to Cloud NGFW for Palo Alto, and we will hit create. And I'll go to the networking tab first just to show you what we need to prepare. If you go to the, there are 2 deployment types. One is the virtual network and vWAN. Today we will focus on the virtual network. So if you see, let me show you, I'm going to insert the Palo Alto Cloud NGFW in an existing VNet. So I want to show you how to prep that. And you can always create a new VNet. But in my case, I have, let me go to the virtual network, sorry. So let me show you the VNet where the Palo Alto Cloud NGFW will be deployed. So here, this is my VNet, and here I've created two subnets. As you can see, the bottom two over here, public and private. And notice that in the delegation, I do have, let me expand the screen so I can show you the delegation. And you could see here that these two subnets are delegated to Cloud NGFW/firewall. Okay, so that is important. If you don't have this set up, the deployment will fail. Now that we have the virtual network set up properly with the two subnets, let's kick off the installation of the Cloud NGFW. So we'll create a new resource group. We'll call it demo. We'll call it Cloud NGFW demo hub RG. So to differentiate that from the one that we've already created for the vHub, and we'll call this Cloud NGFW hub. We'll drop it in East US 2. And we did a deep dive discussion of marketplace plan in the vWAN, so be sure to check that out. But for now, I have the marketplace plan already here. Of course, there are two options. One is the pay-as-you-go, or you could get credit from Palo Alto. And then next, we'll make sure you pick the virtual network. We'll pick the VNet that I just showed you, and we'll pick the two subnets that has the right delegation. So the two subnet are, first we'll pick private, so match the private with private, and then we'll pick the public. Okay, and then of course the public IP configuration will say create new. SNAT, we want it to be enabled for outbound traffic, and then we'll create a different IP for SNAT over here, just exactly how we did it in vWAN. Of course, you could use the same IP. If you pick this one, it will use the same IP. Okay. Public IP, and you could pick different IP or the same IP. Okay, and additional prefixes, if you had additional prefixes, you can set that up over there. Go to next. Security policies. Earlier, we did a deep dive on the three different methods, the Rulestack, Panorama, and the Strata Cloud Manager. So we'll pick Rulestack, and we'll say create new. By default, the default setting is allow all. We'll DNS proxy disable. We'll hit next. We'll accept here. We'll agree, and then we'll hit review and create. Anything you want to call out in this one, Salman? Anything you want to highlight in the deployment that you've seen in the field?
Yeah, I want to highlight the CIDR range minimum requirement because we support auto scale. So we want to make sure that you have IP addresses available when we do auto scale or when we add more firewalls. So for the hub VNet, the minimum requirement is /25. And for the public and private subnet, the minimum requirement is /26. So make sure whenever you create hub VNet and public and private subnet, you follow the guidelines.
Excellent call out. Thank you for sharing that. Yes, and anything along the lines of the licensing or the marketplace plan, we covered that, but just for the completeness of this.
Yeah, so same thing applies. Whatever applies to vWAN Hub applies also here. So you have two plans. You can either do pay as you go. You subscribe to the service and pay directly to the Azure. Or the second thing is you can buy credits from us and you can use those credits to spin up resources in Azure. Yeah. So same two options are available both in VNet and also in the vWAN Hub deployment.
Yeah, so the pay-as-you-go is built through Azure, and the credits will be through Palo Alto. You have to reach out to your Palo Alto rep. Awesome, great stuff. All right, so let's go ahead and hit review and create. This may take a little bit, so I'll pause the recording. But I do want to cover some flows while we wait for this to get deployed. So let's look at the diagram for the hub and spoke architecture. And for consistency, I'm going to use the diagrams from the Palo Alto's website. So essentially, we'll look at first internet egress, which is this one. Then we will look at internet ingress, and then we will also look at east-west traffic. Okay, so those are the scenarios that I will quickly show you in terms of the flows. It's very well documented, but let's look at first the egress. So we'll call this internet egress. And here, the most important thing to call out is that you would have a quad 0 route on this spoke, pointing to with the next hop of the internal IP of the cloud NGFW. And then also this traffic from this VM going to the internet will get SNATed to the IP that we picked, and we will verify that in our demo. So that is 1, 2, 3, 4, exactly how the traffic traverses. And then you can see that the Palo Alto NGFW behind the scene has that load balancer sandwich design. So you have the private and the public subnets over there. So anything on the internet egress before we go to the the second scenario?
Yeah, so I think the other thing to note is the public subnet, because it's in the customer VNet. So we have to make sure that we take a look at the NSG and allow any protocol. So if you are, for example, if you're trying to do SSH or trying to do any HTTPS, we make sure that NSG we enable those protocols. Yeah, because that's customer responsibility to update those NSG that's are in customer VNet.
Great point. So yes, so in addition, so for inbound and outbound, right? So
Yes,
by default, all Azure NSGs do allow outbound, but in case a customer has set up something, but it would definitely be more applicable for ingress. Yeah, great call out. So there is an NSG that sits at the subnet level in Azure. Yes. Perfect. So, and likewise, ingress, let's look at the ingress path. So coming from the internet to, let's say, a VM in Azure or a service in Azure, and following this 1, 2, 3, 4, two important callouts over here, that here the traffic is DNETed first, and then when it leaves the firewall, it is also SNETed here at number 4, so that when this VM sees the traffic, it will see the private IP of the cloud NGFW. So pretty straightforward. Both DNET and SNET will be done, and of course the the return traffic will, because it's SNETed, will go back to the same firewall. Anything you want to call out in the ingress scenario?
No, I think it's straightforward. Yeah, just make sure that you configure DNET. Yep.
Yep, perfect. And then east-west. So this is the, and then we'll just call this east-west. In east-west is also pretty straightforward. Really, this NGFW makes the VNet architecture very, very simple and quite sophisticated in terms of the experience. So going from this server, let's say, to this other app server, that it would follow the default route to the internal IP of the cloud NGFW. And then notice that there is no SNAT over here, right? So this VM would see the real IP of this VM. So pretty straightforward. Anything you want to add here, Salman, or are we good?
No, I think we're good. Yeah, straightforward. No need to configure any DNET or SNET because it's internal traffic, right? So it will just hit the internal load balancer. Yeah.
Perfect.
Straightforward. Yeah.
Perfect. And here, let's go see how our deployment is doing. It's still deploying, and so I'll pause the video and then we will show you the end-to-end demo. We'll just jump on a VM. I've set up a VM. We'll set up the quad 0 route and we'll do the tests. So I'll pause the video here. Deployment is now complete. So let's go to the resource group. We'll take a quick look. Where it looks very similar to the vWAN one. So we have the firewall, we have the Rulestack, and the two IPs, the public IPs and the SNAT IP. Okay, so what we will do is we'll just steer the traffic. We'll create a UDR, steer the traffic towards the firewall. So let's go ahead and look at the firewall IPs here. It should have got it from the internal, the private subnet. So this is this would be the next hop for the UDR. So we'll steer the traffic through this, and let's take a quick look at the networking and NAT. So far, we don't have a DNAT defined, but we do have the SNAT IP over here. So when we do our first test, we will egress using this IP. All right. So I have a VM set up, and for my lab, my VM is actually sitting in the hub VNet, so it's in a separate subnet, but it's in the hub. So my lab design looks, not to create a new architecture here, but just so you have an idea on my lab looks something like this. I just have a VM subnet in the same VNet as where the firewall is, and we'll just steer the traffic. We'll do a UDR to the NGFW. Okay, so very simple, but the same applies for if you have a VM in the spoke. Any question on the architecture or the design for the lab?
No, looks good. Yep.
Okay, so let's go to so I have a UDR here. Let's go to the route table, and you could see that let's just make sure that the next hop is indeed the same IP. So let's just make sure 32.4. Okay, so my UDR has the default route 00 through the virtual appliance, and let's associate my subnet. Actually, before I do it, maybe I should show you a before and an after. So we'll jump on the VM here. So we'll just first run, curl ifconfig.me, and we will be egressing through a different IP once we steer the traffic through the firewall. All right, so I just have the default the default one, and then let's go and attach or associate the right subnet there. So my subnet is called management subnet. That's where my VM is. And so let's go look at that. And we will also look at, if you look at the IP adder, I am once into 16.1.4. And let's also duplicate this tab, look at the effective routes just to make sure. We'll give it a few seconds. You can see that the management route table is associated here, and that the new default route, the quad 0 route, is now pointing to 32.4. And so now we expect that the VM will egress using this 9.169.170.120 IP. So let's run the command again. Let's jump on the console, and then we will run the curl command again, and let's see what happens. So I'll pause the video here. So picking up where we left off, we paused the video at this point, and we were troubleshooting what was going on. So in these series, one of the things that we do is we share the troubleshooting tips as well, and do some real-time troubleshooting as well. So we want to share what we have found. So here, in terms of the troubleshooting, we deployed the whole NGFW again, just to eliminate any issue. The second thing we did was we went, and in the interest of time, we've saved all these screen captures. We ran network water, the connection troubleshoot. It is indeed showing that the connectivity is failing, but it's not showing the resolution. We also looked at IP flow verify, which shows that outbound access is indeed allowed. So let's go switch it to outbound over here. So from the VM, we are reaching out to the internet on port 53. This is Google's DNS server. And as you can see, it is the access is allowed. And the third test we did was NSG diagnostic for outbound, and that is also allowed. But this didn't pinpoint exactly what the issue was. So Shruthi, I know you helped me with this, so for the benefit of our viewers, let's walk through how we went about and did the troubleshooting.
Nihali, let's start with the NSG on the private subnet for the Palo.
Right here. Okay, so these are the two subnets in question, private and public.
Yes, so let's look at the private NSG security group hub. Yes, that one. Let's look at the inbound rules, because what I was talking about is VM is initiating the traffic, so it's an outbound flow for the VM, but the traffic gets into this private interface or the trust interface of Palo, and the destination is a public IP. And here we have no rule that which allows public IP.
So source virtual network, destination public.
Yes. Let's try that and see.
I see. So just from a visual standpoint, initiated from the VM, hitting this private subnet inbound.
Correct.
Inbound,
okay. Yes. Okay. Inbound rule from Palo's perspective. Yes.
All right. So we'll just add source any, destination any, and this is the private interface. So we could put destination maybe 80, 443, right? And it's allow. Okay. Okay, so we're allowing outbound 80 and 443. So that's let's try this again. Ooh, yeah, that did it, Shruthi. So 27.158. So that is indeed that obviously has changed because we redeployed the firewall. So let's capture those screens as well. And 27.158 is indeed the SNAT IP. So excellent. So this is a good test, and let's just capture the management route table as well, because we redeployed. So management route table. So we do have a default route pointing to 172.16.32.4 that still stays the same. The private IP is still 32.4, and then the subnet is associated. This is where my VM is. So making sure we capture that, And let's quickly run a refresh this to make sure, and you can see that it is steering the traffic through the Cloud NGFW. So with that, we have one more test. Shruti, anything else you would like to add here before we go to the DNAT?
No, I think I'm good.
Good. And we don't need anything in the public NSG. Maybe we should capture that as well before we add the DNAT rule. So let's go
Not for
back.
outbound. Yes.
Yes. So let's see. But DNAT would be inbound. So let's go here
Yes.
and so we'll look at the public. And for the public NSG, so this is associated with the public subnet, there is no inbound allowed rule. So let's go ahead and add the DNAT rule. So we'll do the exact same test as before. Let's get the VM ready first. So here we will get the VM ready. We'll have it listen on port 8000. And let's just make sure that VM is indeed allowing port 8000. We'll have to clear off this. We have the defender rule kicking in. So let's just allow 8000 for now, inbound on the VM level. And then let's create the DNAT rule. So here we are in the Cloud NGFW networking and NAT section. We'll hit edit and create a DNAT rule. So DNAT to VM, TCP, front-end IP, we'll use the public IP. This is the public IP of the NGFW, 8000, 8000, and oops, sorry, backend IP is 172.16.1.4. I'll just double check. 172.16.1.4 and 8000. So at this point, we should be able to hit it from outside using this public IP. So we'll just go ahead and hit save over here. And let me get my other screen ready so that we can test it from outside. So it looks like this has completed. So we'll grab this public IP here. This is the command, and that is also failing right now. Should we look at the NSGs?
Let's go ahead. Yes.
We do have the DNAT rule going to 172.16.1.4, and we checked everything. All right, so let's go back to this is the public NSGs, and we'll add an inbound rule. So we'll say source any destination, and we'll say port of 8000. So let's add that. So this is inbound on the public subnet. And so let's go ahead and try it again. And sure enough, it is now working. So east VM, and then if we go on the VM itself, we should also see that it is indeed coming from the 32.6, which is one of the IPs on the Palo Alto private subnet. So anytime I hit it in the other window, you could see that it's cycling through a few of the IPs. So great, that completes inbound and outbound. So as I mentioned earlier in the video, this orange flow is the DNAT, and the green flow going out is the SNAT, which is going out to the internet. And in my case, my VM is in the same VNET as where the Palo Alto NGFW is, but you could very well have it in spoke 1 or spoke 2, and then you have a UDR. So this reminds me of something that I missed covering in our previous scenario. So let me just go jump back here. So there is a setting in under networking and net. If you look at, there is a setting for private source net. So let's say going from spoke 1 to spoke 2, so private to private, the default behavior is that it is not SNATed. That's right, Shruti?
Absolutely right. Yes. Private traffic is not source NATed. Yes.
Okay, perfect. Thank you. So thank you everyone again for joining. Thank you the Palo Alto team for your partnership. Salman, it has been great working with you, and all the great updates, and the Strata demo was amazing. And Shruti, Mays, and Daniel for your presentation and support. I do want to share the incredible amount of work that Shruti and Mays have done. So let me share some blog links over here. So here I have Shruti's blog about network redundancy from on-premises to Azure VMware. Lots of great deep dive information. Be sure to check those out. This is some of the patterns. This is one of the best blogs that I've seen. Some of the deep network patterns and explanation over here. This is in our community blog. We also have an amazing blog from Maze. Maze shared some scenarios earlier, but I do want to, I'll put all of these links in the description below. So be sure to check those out. And lastly, I do also want to share that all of the diagrams and everything that we shared today, will put the links in the description. And thank you everyone for joining. I hope you enjoyed this video, and we will see you in the next video.